Okay, so today we're going to be doing some unbalanced force examples. If you're preparing for our summative or wanting to do more practice with these types of problems, this is a good video for you to follow along with. Okay, so unbalanced forces. Unlike the balanced forces unit, we can tell that the forces on an object are unbalanced if they have an acceleration, if the object is accelerating. So in this case, we have an acceleration of positive 2 meters per second. So this helicopter is accelerating, and it looks like this. And then we also know that the helicopter has a mass of 4,600 kilograms. Okay? What this question wants to know is what is the lift force or the upward force acting on the helicopter to cause this acceleration? Now, one thing that's important about this unit that you understand is that the direction of the acceleration here is actually going to tell you something very important about the force diagram of the system. In this case, and in all cases really, the direction of the acceleration tells you which force is going to be longer and in which direction. So here we've got a force diagram for the helicopter, and when it's in the air, we know that the force of gravity acting on it is going to be 9.8 newtons per kilogram times its mass. Okay, so this is just the force of gravity equation. This 9.8 comes with the equation, and this is given to us in the problem. So I've got my calculator here on the side. And we know that this is going to have a force of gravity of 45,080 newtons. Okay, now back to this acceleration. It's accelerating in the positive direction, so that tells you that the upward force is winning. It's winning this battle in accelerating the helicopter. And it just so happens this force is the one that the problem wants us to figure out. Okay, so here we've got the lift force, and we want to figure out what that is. That is the answer to this question. Okay, now one thing we also want to remember is that there's also something called the net force. And the net force is really just a number that tells you, all right, there's a force that's winning. How much is it winning by? How much more is it longer than the other force that's opposing it? Okay, so one way to figure out the net force is to actually take the difference, because I'll work here on the right. The net force is really just the difference of the upward force and the downward force. But the other thing is, and you will always have to use both of these definitions of net force, another way to find the net force is by Newton's second law, which is just the net force equation here. Okay, so we're going to go here and get the net force. And it's just the 460 kilograms times the positive 2 acceleration. And going back to my calculator here, which I have off camera. And I'm getting 9,200 newtons for the net force. So notice that one common mistake I'll see students do is, all right, they'll go ahead and plug that in here and say, that's our answer. Okay? Unfortunately, that life's not that simple, because we can check on that. And that number here, it doesn't make sense for that to be the upward force, because we just said that the upward force has to be winning. in no way is 9,200 more than this number here. Okay? The way to use the net force is to remember that the lift force is winning by this much. It's beating this number by this much. Okay? So in other words, I'm going to switch to blue here. Whatever that lift force is, once we subtract away the downward force, we are going to get back the net force. Okay, and this is how you solve all these types of problems. You will have to use both definitions of the net force. So once you do this, all we have to do is get the lift force by itself. And I'm going to move down here, and then we've got 45,080 plus 9,200, and that gives us 54,280 newtons here. And that's your first example problem. Okay, another type of question you'll see on your summative is a net force problem or an unbalanced force problem that occurs sideways. And what I mean by that is in the previous problem, the net force, all that action happened up and down. Okay? All we're going to do in this type of problem is turn it sideways so that all the action happens left and right. So here's an example. First, we've got a refrigerator, which has a mass of 120 kilograms. And we know that's being pushed by the person. So we'll go ahead and draw our force diagram here on the refrigerator. And let's just go ahead and get all the forces. We know that this person will apply a normal force to the refrigerator. And the problem straight up tells us that it's 600 newtons. Okay? And we're also told that the force of friction is 588 newtons. Okay, and that happens due to the floor acting on the fridge. Now, there are other forces here in play that will likely not come into action here, but I'll just list them off still. So there's a normal force that the floor does to the fridge. And then we've also got the force of gravity that the earth does to the fridge. So these are still good because I will also be looking for these forces as well. And we could go ahead and find this as well, which might as well do. This is the 9.8 newtons per kilogram times 120 kilograms. That gives us 1176 newtons. And since there's no acceleration happening in the up and down direction, right, the fridge isn't floating into the air or crashing through the floor, these are also the same. Okay? Now notice that the unbalanced stuff happens here in the horizontal direction. So the forces that are going to be of most interest to us in finding the acceleration, which is what the problem wants, is these two forces. Okay, so let's go ahead and find that. I'm going to switch to blue real quick. And since I'm working with the force on force diagram, it's the forces that point right minus the forces that point left. So in this case, 588 points right and 600 points left. And the difference is going to be the net force. And I do not need a calculator for this one. This is negative 12 newtons. Okay, that's not the answer because we want the acceleration here. So we need an equation that involves forces and the acceleration. And there's only one force that does this, or one equation rather that does this. It's the other net force equation, right? Remember in the last slide, I did say you will have to use both of these equations. So when we found this negative 12, it actually serves two purposes. Not only is it the difference of these two numbers, but it also is equal to the mass of the fridge times its acceleration. So when we go here, I can plug this in for the negative 12. I've got the mass of 120 kilograms, and all I need to do is figure out the acceleration. So when we divide, the acceleration is equal to, let me just double check here because it's early in the morning. Yep, it's equal to negative 0.1 meters per second. And there you go. Your two example problems for the unbalanced forces summative. Hope this helps, and I'll see you in class.